Good day, team, colleagues, and guests. I am Engineer Shermaine Doroja, and today I'll be presenting my research entitled Computational Optimization of Solid Waste Management in City of San Jose del Monte, Bulacan, a MATLAB-based approach. This study explores the integration of computational tools, specifically MATLAB, in the optimization of solid waste recycling systems, with a focus on urban municipalities such as City of San Jose del Monte, Bulacan. As urbanization accelerates across the Philippines, local government units are increasingly challenged by the growing volume of municipal solid waste. Despite the presence of national policies such as Republic Act 9003 or the Ecological Solid Waste Management Act, still many LGUs rely on outdated and inefficient collection systems. Recycling, while mandated and promoted, often suffers from logistical inefficiencies, lack of infrastructure, and poor community compliance. This study was conceptualized to address these systematic challenges by leveraging data modeling and simulation to propose optimized data driven solutions for recycling operations. To build a model capable of solving these issues, I started with a data pipeline. My sources included academic literature, news reports, official LGU documents, and data sets from National Solid Waste Management Commission. Where barangay level data was limited, so I created synthetic data for 10 representative barangays, namely barangay 1 through 10. Key inputs included annual waste generation per barangay, fraction of compostable waste, distance to a centralized material recovery facility, cost per ton of collection and disposal, geographic coordinates for spatial modeling. To simplify the model, I assume constant waste generation throughout the year, calculated Euclidean or state line distances between the locations, modeled only one central MRF, and assume adequate vehicle capacity for all barangays. So these assumptions help streamline the modeling process while capturing realistic urban-based behavior. The next step was optimization. The MATLAB-based model had two main objectives, which is to minimize operational costs and maximize compostable waste recovery. The total cost function include both the per ton processing cost and transport cost, while the compost recovery function estimates the recoverable organic fraction. For routing, I implemented a traveling salesman problem variation using interlink prog from MATLAB's optimizational toolbox. So the process involved creating a distance matrix, defining constraints and variables, solving the model, and last is visualizing the optimized route. The result is a route that efficiently connects all barangays to the MRF, reducing redundant travel and maximizing time and fuel efficiency. The analysis yielded several insightful results. First, waste generation varied significantly across barangays, with barangays 3, 6, and 8 emerging as high volume generators. This makes them ideal targets for focused collection efforts and composting interventions. Second, I observe an inverse relationship between composting capacity and operational costs. As composting infrastructure expands, the cost of transporting and processing waste significantly drops. This suggests a compelling investment case. Improving composting facilities not only benefits the environment but also leads to long-term cost savings. For local governments, this insight helps in prioritizing both budget allocation and infrastructure. When you look at the composting potential, barangays 3, 8, and 10 showed the highest yield of compostable materials. These areas are ideal for implementing targeted waste segregation and composting programs. The optimized routing algorithm was also very effective. Compared to standard route, the model achieved a reduction in travel distance, which is a major improvement that directly translates to lower labor and fuel costs, reduced carbon emissions, and shorter collection times. These show how computational tools like MATLAB can convert raw data into practical implementable insight. that benefit both city operations and environmental. To conclude, the study demonstrated how MATLAB-based computational model can significantly improve the efficiency of solid waste management system in our urban setting like City of San Jose del Monte. Some key achievements included such as cost reduction through optimized routing, improved compost recovery rate, reduced fuel use and vehicle emissions, and more informed data-driven decision making. However, there were limitations. The model used synthetic and static data and relied on Euclidean distances instead of actual road networks. So, for future research, I suggest integrating real time IoT data to allow dynamic routing, using machine learning models to forecast waste volume, applying multi-objective optimization to include health and social impacts, and incorporating GIS data for more accurate and realistic routing. Ultimately, this study shows that with the right data and tools, local governments can transform their waste management system into efficient, sustainable, and cost-effective operation. To close, I would like to leave this thought. MATLAB is not just a tool. It's a bridge to innovation, empowering minds to transform data into groundbreaking solutions for tomorrow challenges. Thank you.